All right, so we're going to do practice set 5, chapter 7. This is your practice set that starts off with the number of lithium atoms and 4.5 moles of lithium. So I'm going to start with 4.5 moles of lithium. So we're going to subscript that Li. And basically for this first slide, what we're looking at is Avogadro's number and the periodic table. So how to use molar mass and how to use Avogadro's number. Now we're in moles and we want to get to atoms. So that means we're going to be going from moles to particles, which means I want to get rid of moles. So I'm going to put 1 mole on the bottom and Avogadro's number on top. So 6.02 times 10 to the 23rd. And of course that would be atoms. Didn't give myself enough room there, but that's atoms of lithium. Now I'll run that through my calculator. So I'll take 4.5 times 6.02. That's going to be 2709. There's 27.09. And at this point, don't forget we have that times 10 to the 23rd. So I'm going to bring that out. I didn't use that in my calculator. And that's going to be atoms of lithium. Now, if I stop here, I'll get partial credit, but this is not my final answer. So what I'm going to need to do is move this over one place because I can only have one number in front of the decimal point. And secondly, don't forget those pesky sig figs. We have 2 significant figures going in, which means we're going to expect 2 significant figures to come out. So my final answer then is going to be 2.7 times 10. And now, because I moved this decimal point over one place and I made a big number small, my exponent has to grow. So this is going to be 24. And then, of course, atoms of lithium. And that'll be our final answer. So 2.7 times 10 to the 24 atoms of lithium. Now for molecules, again, we'll be doing the same sort of idea here, looking at the mole versus molar mass versus particles. There is a flow chart. It's provided for you in the student resources tab. So there's a little flow chart there to help you with these calculations. So feel free to take a look at that. As far as process, we'll do the exact same thing, except this time we're going to use 0.0180. Remember, this 0 is significant, so that's going to be 3 sig figs here. Moles, and this time it's going to be the molecule CO2. Now we're still trying to get to particles. This time the particle we're trying to get to is molecule. So we're still going to have 1 mole on the bottom so that the moles can cancel out. And we're going to have Avogadro's number on top. Now remember, Avogadro's number is particles. So you have to be careful with this because you're going to pick which particle you want to go to. And the way you're going to depend that is going to depend on what it is you're going to from the moles, right? So we have moles of lithium here. That meant it was going to be atoms. Here we have moles of CO2. So this has to be molecules. Now the question is asking us for molecules, so that works out. But later we'll see that I could actually ask you for atoms of, say, carbon in the CO2 or atoms of oxygen in the CO2. You'd have to add an extra step here to get that isolated into atoms. So the first step is to get to molecules, then get to atoms. In this case, we're being asked for the molecules, so we're only going to have that one step. We're now going to run that through our calculator. So we're going to have 0.0180 times 6.02, and that's going to give me 0.1084. And again, I left that exponent out. So it's going to be times 10 to the 23rd. And this would be molecules. Once again, I can't leave this number like this. So what I'm going to do is I'm going to go ahead and push that here. That way we have just the one number in front of the decimal point. We pointed out earlier that this 0 is significant. And so we have 3 sig figs here. So I'm going to keep the 1, the 0, and the 8. So it's going to be 1.08 times 10. Now this time we made a small number large, which means the exponent has to go down. And so this is going to be 10 to the 22 molecules of CO2. Now, if you forget to subscript the CO2, or in the first one, if you forgot to subscript the lithium, it's no big deal. You do need to have the unit, however. So you do need to tell me that this first one was atoms and that the second one is going to be molecules. Okay, so you do have to have units with your answers, but it doesn't have to be subscripted with the correct thing. Now, later on when we do stoichiometry, that's going to be a very important part. So I would suggest that you get into the habit of subscripting, just because when we start having multiple things in our reactions, it's going to get a little confusing. You'll forget which moles went to which thing. All right, so for C, we're going to be working it backwards. So here we were going from moles to particles. Now we're going to go particles to moles. So we have 7.80, whoop, just 8, no 0, times 10 to the 21 atoms of copper. And this time we want to get rid of atoms. So we're going to let Avogadro's number be the particle, and we're going to put it on the bottom. 6.02 times 10 to the 23rd atoms. And it'll be 1 mole on top. So remember, we can flip-flop this depending on how we want those units to cancel out. I want the atoms of copper to cancel out, so that can be moles of copper. Okay. And I'm going to run that through my calculator. And so I'm going to take the 7.8, I'm going to divide that by 6.02. That's going to give me 1.29 times 10. And I'm going to use the rules for exponents here. I have 21 being divided by 23. That means I'm going to take 21 minus 23, and that's going to give me -2. And that's going to be moles of copper. Now at this point, I just need to fix my sig figs, but I could just leave it this way for the most part, circle it and call it a day. Or, because this is a -2, we could get rid of that, so we could move this over 2 places. So that's going to give us 2 potential answers. We could have 1.3 times 10 to the -2, or we could simply get rid of that 1, 2, and have 0.013. Either case, your unit would be moles of copper. All right, I'm going to go ahead and erase the slide here. Maybe. There we go. Okay, so for this last one, moles of C2H6 in this many molecules, and that's ethane in for molecules. So we're going to do 3.75 times 10 to the 23rd molecules C2H6 again, we want to get into moles, so I'm going to put 1 mole. Put ETH, it's ethane, and that's going to be over 6.02 times 10 to the 23rd. All right, so we're going to take 3.75. We're going to divide by 6.02. That gives us 0.623 times 10. 23 minus 23 is going to give me 0, which means my final answer is going to be 0.623 mole. And we could put ethane down here if we want, or C2H6, or however you want. And that would be it. So that's slide 2 of this homework set. And I think what I'll do is I'll make a video for each slide. Looks like it'll be about 10 minutes long or so, and that'll probably be plenty of time. And that way you don't also have to go through the entire video to see the answers you need. All right. So stay tuned for the slide number 3, which will follow this one.